Hi there, this is a video about the properties and attributes and hierarchical classification of 2 or 3 dimensional figures. The first thing that it asks us is what is the area of a rectangle or triangle? And the first thing that we want to do is first talk about what the concept of area is. This is a 2-dimensional measurement, all right, of the space that an object takes up, okay? So if I have a rectangle here, all right, and I want to talk about a rectangle first. Now remember, we've got 4 right angles in a rectangle. Opposite sides are congruent, and the diagonals, well, let's just leave it at that. So this is your base length here. This is your height here, all right? And what we can do, given those 2 measurements, we can calculate the area. So the area, we are simply just going to do the base and multiply it by the height, okay? Now this is for a rectangle, okay? Now if I wanted to come in here and cut this in half, all right, then I use my formula for the area. I would just divide that in half. So in this, I have a triangle. All right, so the area of a triangle is simply going to be the area is equal to base times height divided by 2, or you could say that that's 1/2 times the base times the height. All right, and so those are your formulas that we use for area of a rectangle or a triangle. All right, and so we have to use the area of a rectangle to figure out what the area of a triangle is, because a triangle is just half of that. The next thing that we're trying to do is we want to calculate the area and the circumference of a circle. So in a circle, what we have is we have a couple of different measurements. We have the measurement from the center of the circle to the outside, and that's called your radius. All right, the other measurement that you have is from one side of the circle to the other that passes through the center, and that's your diameter. Now remember that your diameter is equivalent to 2 times the measure of your radius, okay? Now you can also say that your radius is your value of your diameter divided by 2, okay? So depending on what you've got, I'm going to use this formula here to calculate the area and the circumference. So what we have here, the area formula, is we take the number pi, all right, and remember that the number pi is equivalent to approximately 3.14. So pi times your radius squared will give you the area of your circle. And if you wanted to calculate the circumference, the distance around the circle, also, think of it as like the perimeter of your circle, is equal to pi times your diameter. And since your diameter is equivalent to 2 times your radius, sometimes we also say pi times 2 times your radius, all right? And you could even, a lot of times you'll see this formula as 2 times pi times your radius. Doesn't matter, that's the commutative property, meaning that you can reorder things that you multiply. Another concept that we need to talk about is the perimeter, and the perimeter is the distance around an object, okay? So one thing that you can always do is just add up all the sides, okay? But there's a formula for this. So like if you had a rectangle here like we had before, and with these as 90-degree angles, and this is the height, and this is your base, what you would do is you'd want to write, instead of saying, your perimeter is equal to base plus height, okay, because this would be your height, and this would also be your base. All right, because you have 2 of these and you're adding them together, you can use the formula 2 times b plus 2 times h. All right, and that's what you would use, okay? Now, sometimes you'll often see things with, length and width, all right, and it would be the same thing. The perimeter is equal to 2 times your length plus 2 times your width, all right? And we could write it like that. The next word that we had is this thing called parallelism, and when I think of just the word parallel, This means two lines that run side by side and don't touch, okay? Don't intersect, rather. And so when we think of, say, a rectangle, we have two pairs of parallel lines here. All right, so in one, these opposite sides are parallel, and these arrows indicate that they're parallel, and then these opposite sides are also parallel, and that indicates that they're parallel. And so a rectangle is a type of parallelogram where your opposite sides are congruent and parallel. What makes a rectangle different is that it has 90-degree angles, okay? And that's the idea. Now, another thing that we can talk about with parallelism is if you have two parallel lines cut by a transversal, all right, so I'm going to call these lines parallel. What I know is that there's a lot of angle relationships happening here. All right, and what I want to do is come in here and just name some of these angles. So I'm going to say that this angle here is 60 degrees. All right, that means that if these two lines are parallel here, that a lot of these other angles are 60 degrees. So this angle is going to be 60 degrees, this angle is going to be 60 degrees, and this one is also going to be 60 degrees. And then I can come in here and say that this angle here is 120 degrees. All right, this angle would be 120, this angle would be 120, this angle would be 120. All right, and what you want to think about is, you know, these angles that are across from each other are called vertical angles. These two angles here correspond, as well as these angles here. And then the ones that are next to each other have to add to 180 degrees. So when I called this one 60, I could figure out all of the other angles, all right, and figure out what those were. So that's what I think of when I look at when I think of the word parallel. The last word that we have is this word called volume. Okay, now volume is a three-dimensional measurement, similar to area, but it's a three-dimensional measurement of the space that an object takes up. So three-dimensional measurement. And so what I want to do is think of just as a rectangle, okay? And so if I take a rectangle, all right, and if I, think of this as the base, let's do length and width on this one. So length and width, all right, and that's 2 dimensions, okay? When I add in that third dimension, I'm adding in the height, all right? And so if I want to calculate the volume of an object, then what I want to think about is that the volume is equal to the length times the width times the height, okay? And so that's what I'm doing, is you're adding in that third dimension. When you multiply dimensions by itself, when two-dimensional figures, I was just multiplying 2 dimensions. When I add in that third dimension, that's what gives it volume, okay? The other thing that we can put here is a cylinder as well, all right? So let's say I have a circle, think of a can or something like that, and I have my radius here, r, but if I add in that third dimension and give this some depth, then all of a sudden I add in my height. And if we think of the area of our base, of our circle here, the area is equal to pi times your radius squared. Well, to get volume, you simply just add in the height. So you get pi times your radius squared times your height, and that's what you would get for something like that, okay? So all the things kind of build on itself, all the properties of a rectangle, circle, all those little things are really important because we build off of them. So in order to understand a concept like volume, we really have to understand the concept of perimeter, circumference, area, and all that good stuff of all those different figures. So hopefully this helped, and let me know if you have any questions. Thanks, bye.